Don Selle is a former president of the Houston Astronomical Society, been a member of our club for quite some time. But since 2003, Don has been an avid amateur astronomer, an astro-imager, and a member of our club. Starting out with only a basic knowledge of photography, he has learned the ropes and has become a competent astrophotographer and nightscape imager. After 20 years of learning the craft, he is still striving to complete that perfect astro image that knocks the socks of those who view it and wins multiple awards. Don, I think you're getting there, so I don't think it's far off. Don acquired his first camera tracker in 2017 after his equatorial mount bit the dust just weeks before the Great American Solar Eclipse. The camera tracker realized his plans to photograph the event and did a fine job to boot. In 2019, he won a second camera tracker as a Star Party door prize. Was that at TSP or was that a different Star Party?
No, it was Okie-Tex.
It was Okie-Tex, okay. This one fall sealed his interest in using the camera trackers for astro-imaging, and he's been perfecting his technique ever since. So, Don, thank you very much for joining us tonight. We're looking forward to learning more about camera trackers for astro-imaging.
Okay, thank you, Joe. I'm going to try and share my screen here, see if I get the right one.
While you're doing that, Don, I was just going to remind everybody, if you don't mind, if you have questions for Don throughout the course of this presentation, please use the chat function that we have here in Zoom. Ask your questions there, and we'll get to those in the order that they're received. So thanks, Don.
Okay, no problem. I really appreciate the opportunity to talk with you all tonight because as Joe mentioned, I've been doing astrophotography for better part of 20 years, and also been a part of HAS for that whole time. And I've noticed this.
I'm sorry to interrupt you one more time. The screens are flipped for the presentation.
I'm sorry, say again?
Your presentation screen is flipped, so we see the presenter view.
Okay, yeah. Let me see. Maybe I'm sharing the wrong screen.
Could be. And you can go to the top there where it says display settings and actually swap screens if you want to as well.
Hang on. Let me do the new share. Okay.
Yeah, I apologize for interrupting you there,
No
Don.
problem. No, that's fine.
There we go. Looks good now.
Okay, good. So now I just have to get the rest of it up here. And at any rate, I guess the point I was trying to make is that when I started in astronomy, I immediately gravitated to astrophotography, and frankly didn't know what I was doing. And I've noticed, especially nowadays with the technology getting better, it seems like so many of our newer members are attracted and want to get involved in astrophotography. So I'm trying to pitch this presentation at those of you who are new to astronomy and are interested in astrophotography. So let's go to the next slide. What are star trackers? I tend to call them camera trackers. It's kind of an interesting development. What started to happen about 15 years ago was that night sky photography got very popular. Nightscapes were starting to be seen everywhere, and there was a lot of interest in doing good ones. And from the photography side, all of a sudden some new tools popped up. The first one was like this AstroTrack star tracker here, and these more simple ones followed. After a little bit of time, the manufacturers of astronomy equipment realized, hey, there's something going on here with these star trackers, and maybe we should get in front of this whole movement because it could be a good way for us to sell our equipment to new astronomers, because it seems like a large number of new astronomers want to get into astrophotography. So we started to see things like the Ioptron star trackers, and then Skywatcher got in the race. And I would say right now that those are the two primary contenders for star trackers from the astrophotography side. In fact, Skywatcher has recently released a brand new one which is a go-to model, and I would actually call this more of a lightweight mount than a camera tracker. But okay, who's counting, right? So as the technology has gotten better, so have the trackers. But I have a confession to make. I'm coming to this. I'm sort of a reform. You know how people that have bad habits get reformed? They get religion. Okay, I started out kind of bad in astrophotography. At the time when the advice was get an 80 mm refractor and a German equatorial mount, I started out with Schmidt Cassegrain, 2000 mm 8-inch Meade, and tried to make it work for astrophotography. It was a real struggle, and but I learned a lot, right? And fortunately for me, I'm just a stubborn cuss, and so I've stuck with it. Eventually, whoops, I went the wrong way. Sorry. Eventually, I upgraded. There in this hobby, there's always an upgrade. I found on Astromart a 5-inch Takahashi refractor and a EM 200 mount for a ridiculously low price, and all of a sudden my astrophotography got better. So I went along with this for a while until what finally happened. And in the introduction, Joe touched on it. A few weeks before I was getting ready to go to Jackson Hole to view the Great American Eclipse, I had plans. I had two mounts, that EM 200 and a smaller one that I was going to put my camera on with a 300 mm lens. I wanted to do some science imaging with the bigger telescope and the bigger mount, but the mount died. So now all of a sudden I'm short. I've got to make up the difference, and did a little quick research. And at the time, this Ioptron Sky Guider Pro was probably the best sky tracker out there. So I got it, and it was only really the fact that I needed it as a stopgap that I put my camera with a 300 mm lens on it to photograph the eclipse. So it just got me started thinking, this is really simple, and maybe it's something I should learn how to do. So I want to because I want to address the new astro-imagers or the aspiring astro-imagers. Here's what I hope to achieve with this presentation. Hopefully by the end of this presentation, you'll come away with an understanding of what a star tracker is and how they're used, and then how you might be able to use a star tracker to improve just your basic night sky photography, like for example, nightscape imaging. If you want to go deeper into learning astro imaging, maybe a star tracker would be a good entry point for you. They're not hugely expensive, and if you already have a decent camera and a decent telephoto lens, you're more than halfway towards being able to get started in astro imaging. And then, as part of this whole process, I'm going to kind of develop a few concepts and techniques that you're going to need if you starting out, and then in the future as you get deeper into astrophotography. And all along throughout this, there's a lot of material to cover, so I'm going to touch on a lot of it lightly, but I'm going to provide you with some websites specific with a lot more in-depth information specific to the different areas. And I will, if everything goes right, I'll put them on the chat for you to copy off. Okay, so just to start out with, I'm going to try as much as possible to be brand agnostic. I have owned the two kind of most popular star trackers from the astro-imaging point of view, but there's a lot of good ones out there, and I think it's important for you do the research yourself and make your own decisions for buying. I'll get into very shortly what we can use a camera tracker for. How do we set the equipment up? What's it look like? What kind of upgrades beyond just the camera tracker and your camera? What are some of the things you're likely to want to have? And some of the concept, polar alignment, how to focus, how you do figure out exposures and calibration frames. What the heck is a calibration frame? And then at the very end, I'm going to do a very, very light introduction to a basic image processing workflow, but I'll point you at some more resources that go in a lot more depth than I have time for here. So here's a couple of the websites for you. Now I got to pull them out of the chat, right? Okay, so if you are interested in learning more about no, that's hard. I thought I could copy this out of the. I thought I could copy this out of the notes, but that's not working. Okay, I will get them and put them in from. I should have a list of these. Okay, you're going to want to know what the best star trackers are, right? So there are plenty of reviews out there, and let's see if I can do this right.
Don, I'll copy those and send them out to everybody in the chat here.
Okay, I appreciate it. I thought I could get them off of the I thought I could get them off of the meeting notes.
Yeah, no worries.
Slide notes, but anyway, okay. I do want to point out that if you're already a photographer, a website with lots of good info is Jerry Lodrigus' site. It's been around for quite a long time. It's called Astropix, and he gets into a lot of good information on from a photography point of view of how you do good astro-imaging. So what are camera trackers good for? Well, I'm happy to say they're good for solar and lunar photography because I did actually use it for the eclipse. Nightscapes. I've actually done one very large nightscape, ultra wide night sky photos, wide field astro-imaging, and a lot of these support time-lapse images as well, though I'm not really at a point where I can do the I haven't done a lot of that with these, but I just want to point that out. I'm not really going to spend any time on it in the presentation. So the Great American Eclipse. This is the image that I captured in August of 17 using that Ioptron sky guider. And the nice part about it was I used I just roughly polar aligned it, and with my my camera and a 300 millimeter lens, it tracked the sun quite well, and I hardly had to adjust it. So hint, 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 for those of you who are thinking of photographing next year's April 8th total solar eclipse, it's a good place to start if you don't want to invest in a bigger mount. The camera I used was a Canon 70D and my trusty 300 millimeter f4. There is you're going to need to get solar filters, and I do have I hope their solar filter. They're in the comments. Bader makes some really good solar filters. You can get them at Alpine Astro. And then there are a couple of programs that you can use that will help you quite a bit. Eclipse Orchestrator, and the second one is Eclipse Maestro. And we'll talk about that a little bit. For the image I did, I processed it all in Photoshop. Make sure you use ISO certified solar filters for all your optics and for your eyes. And frankly, after the 2017 eclipse, there were a bunch of images on the web, which showed people who had destroyed 500 millimeter telephoto lenses because they didn't think they had to have filters on them. Don't be that person. Okay, you don't want to have to pay for the lens. And as I mentioned, automation software is Eclipse Orchestrator and Eclipse Maestro, and both of them work very well. And then really, the more time you plan your Eclipse experience, including the photography, the better off you'll be. And by using the automation software, I was actually able to watch the eclipse with my own eyes and not worry about the photography until after it was all over with. The computer ran the images just perfectly, and literally, I'm extremely pleased with the image I got here. So I think it's if you do want to do photography, do it automated. Put your eyes on the actual eclipse. Okay, here are the different websites for solar filters and the two imaging packages. And just I threw in as well, Fred Espenak has been doing eclipse work for decades. He's got a site called Mr. Eclipse. It's well worth looking at when you do your planning. And then Xavier Juvier has a great eclipse, interactive eclipse map, and he's also the author of the program Eclipse Maestro. So nightscapes. I started out all the way back in 2008. I took my first wide field image of the Milky Way. This didn't come across as good on the Zoom as it looks in an image. But anyway, the point being is that I actually tried to do this photograph in 2017 with a camera and lens that I had, which was not really ideal for doing the image. I was not happy with the results. So I thought 2018 came along. Hey, I've got that camera tracker. It's supposed to help you do nightscapes. So I set it up at the gate to the Prude Ranch and took this stars at night nightscape. The property right next door had an awesome Texas flag painted on a shed, and it just sort of spoke stars at night to me. So basically, this is a 12 panel panorama, 4x3, and as I mentioned, the 70D camera that I had was not the most sensitive camera. It wasn't the best for doing nightscapes. And the kit lens that I had to stop it down to f5 to keep the stars from looking really weird. And as a result of that, because I had when you're on a fixed tripod, the sky moves faster than you can take deep images in. I could only take 13-second images with this setup. So when I used the Sky Guider, I was able to do 45-second images and stacked 5 subframes for each panel. So right away, I almost increased the exposure for each sub exposure almost by 5, 4 anyway. And the upshot was that I was able to get a much better nightscape image. I processed it in Photoshop, but I will say one of the things, if you use a camera tracker to shoot a night sky panorama, make sure you mark it so that you can find the weights down position in the dark. I didn't do that with that Stars at Night nightscape, and I had a terrible time trying to get the panorama to come together in the stitching software I had, both in Photoshop and a couple of other outside ones. So my current camera tracker's got a little white paint line on it, so I know I can put it in the weights down position, and it makes getting that panorama to work a lot easier. There's always an upgrade, and I recently just purchased this Z-Flex pan and tilt head. It's really designed to go on a camera tracker or star tracker, so that because we're polar aligning the camera tracker, you're always going to have the camera pointing at an angle upwards towards where the North Star is. And this device lets you put everything on a level, a camera on the level, and still have the camera tracker move it, and in time with the stars. And this is it's a really well built piece of kit, and I'm just really starting to learn how to use it. But the best upgrade you can do in all of these situations is learn how to post-process your images. Astronomy night sky images are a little different than daylight images. I did get a further upgrade. This I actually shot from a level tripod the next year. I got a better camera, I got a better lens, and so I was able to put together this nightscape there just outside of Fort Davis, and it came out really well. So if you're going to do this, again, it's I got the Canon 6D full frame camera and a Sigma Art 24mm f1.4 lens. And when you're doing night photography, the lower the f number you can use, the better your exposures are going to be in terms of getting lots of signal. Typically, though, if you have a really wide open lens, you're going to want to step it down at least one full stop, maybe more, because the night sky is a great equalizer of all lenses. It shows every flaw in your lens. And stop down, you take the edges of the lenses out of play, where most of the faults come from. So I kind of went through this already. Get the fastest high quality lens you can afford. When you process these types of images are actually composite images. The ground and the sky are lit completely differently, and so in order to get them to even out the way your eye sees them, your eye has a much better range of dynamic range for brightness. In order to even it out so it looks like what your eye saw, you actually have to process the brighten the ground differently than you do the sky. That means you got to learn how to use masks, and there are good AI masking tools that you can get to do this kind of photography. And you'll need to do it whether you use a camera tracker or shoot from a fixed tripod. Okay, so now I've got this Ioptron Sky Guider Pro, and I've used it for a nightscape, actually a couple nightscapes. And well, what happened if I turned it to the Milky Way? And so I was out at the site one night, and I just pointed it up if you're familiar with the Rho Ophiuchus region, it's that region in between the top of Scorpius and Ophiuchus, and it's you can see these dark lanes at night when you're in a dark sky area. They pop out against the background stars with your naked eye. So it's the first image I shot. Only took 45 minutes of it, and processed it in Photoshop. And this was before I had the Canon 6D Astro modified. It did a pretty nice job, I think. I was able to saturate the colors, but this is probably the most celebrated wide field area in the Milky Way. It's certainly the most colorful. And while this isn't the greatest image of all, the fact that it was the first wide field Milky Way image with a star tracker that I took, I think it came out pretty well. So, this is first time out of the box. So if you're just getting started, you can approach this pretty quickly. So just some information on the exposure. I took 1 minute and 30-second exposures for a total of 45 minutes of total exposure at ISO 3200, which is kind of a sweet spot for this Canon 6D. Most DSLRs have an ISO that they work best at for dark sky or low light images. I did take flat field frames and dark frames as well. This is something I learned to do in doing regular astrophotography. And then I used a program, and we'll talk a little bit more about this way later in the presentation, called Deep Sky Stacker. It's a free program, and it does a really nice job of doing all of this calibration. And I did the final imaging in Photoshop. So that was with a 70mm lens. And again, I want to emphasize this is a very big, very bright area of the Milky Way. Later on, I've done some other ones, but I'm obviously highlighting some of my better ones. I shot the North America and Pelican nebulae. This I did in 2021, in summer 2021. And by that time I had the Canon 6D Astro modified. But I shot it with my trusty 300mm f4 lens. Again, this seriously, it benefits from my experience in processing, but the fact of the matter is that the data I got using the camera tracker and this 300mm lens was more than adequate to get a really nice image out of. And I'll talk about the techniques that go into getting the data you need to put something like this together in a little bit. But I also, as an aside, took this image in 2 sessions. I was visiting my sister had a health issue, and so we went up there to help her out in June of 21, and I was outside of Buffalo, New York, and it was really kind of interesting because where I was at, the skies were essentially Bortle 1 if I looked east, and Bortle 4 if I looked west. Fortunately, this was a rising, and I was able to take it in the dark sky area. And then later on in that summer, we actually went up to Ontario, and I took some more images on it as well. This is about almost 3 hours of total exposure. I have had as I mentioned, I've had the full frame camera Astro modified, and I did the astrophotography thing of flat fields frames and dark frames, and this time I used Pixel Insight, and did the processing in Photoshop and PixInsight. So moving right along here, here's kind of a typical setup, I would say, if you're going to do Milky Way imaging with a star tracker. You need a good sturdy tripod. You're going to need, this is whether it's inside the camera. Newer cameras have the intervalometer built into them. Mine doesn't. I have to have an external intervalometer where it's a shutter release. And I always are doing things with external batteries. But you also need to have a comfortable chair because you're going to be messing with this rig, and it's a whole lot easier to do that from sitting down. Tripods. If you have a good sturdy tripod, something that'll carry 25 to 35 pounds of payload, you're in pretty good shape. You can always, if you have one that's a little lighter than that, you can always use the trick of adding a dead weight to the center post of your tripod. I turned out that I had a lightweight tripod that when I took the ball head off it, it only had quarter-inch threads. And a lot of these camera trackers use 3/8 inch threads in the bottom. And I'm here to tell you that they're not real expensive, but you can get a really cute little adapter to take that quarter-inch 20 stud, make it a 3/8 inch stud really, really quickly. So that kind of saved the day for that tripod. And this is that tripod. I want you to be aware of something else. When you do use this camera tripod for a star tracker, you're going to need to take the tripod head off. In order to do that, most of the better tripods I've ever used have had three kind of, call them grub screws or holding screws, whatever you want to call them, that basically lock the head in place. So in order to get the head off, you've got to loosen those first. And then if you did like I did one time and forget to tighten them, it's very easy to move the star tracker when you're least expecting it. And all of a sudden that that star tracker that looked like it was really well polar aligned is showing you stars that look like a streak of Starlink satellites. Okay, so make sure that you do what it takes to get that star tracker to be secure so it can't move relative to the tripod. Another thing that you can do when you have these grub screws, you can get it almost all the way tight. But I like to have one leg of the tripod pointing north. For the reason being is it makes this polar alignment much easier. I can sit behind the other two legs of the tripod, spread my legs out, and I can, from a sitting position, address the camera tracker. If that one leg was pointed south, it would really make that hard to do. So it save your back, set the tripod up with one leg pointing north. The other thing you want to make sure you do, again, we're not trying to get to a certain vertical level to shoot. You want to keep your tripod legs as short as possible because they're more sturdy that way. They're also less likely to get wind buffeted as badly as if your tripod legs are fully extended. And finally, especially here in Southeast Texas, you better check for fire ants before you setting up. The worst thing to do is get in the middle of an imaging session and have fire ants crawling up your pants. Okay. A few recommended accessories. for a basic star tracker. I have a big battery eliminator. This is a big power tank. And I found that if I want to do any kind of long time frame imaging, like when I did the North American Nebula, having just the camera battery barely gets me through about an hour's worth of images. So I switched over. I found a battery eliminator on Amazon, and it plugs in by a USB ports to my power tank, and it runs that very well. It runs the camera very well. It turns out that the Star Tracker also has a USB port, and it can be powered from the same power tank. The one that I have has batteries, 4 AA batteries to power it for its rotation. Excuse me, and I'm using rechargeable batteries, and I always take an extra set with me. I always have a headlamp and my red flashlight, red headlamp, red flashlight. I've mentioned my intervalometer before. This is what I take, what takes multiple frames of the same duration, exposure duration for me. And I always have a roll of painter's tape. I tend to like red painter's tape because it's good for putting over white lights like on this headlamp. And it works just like the blue stuff. I also carry a couple of very long twist ties and some of these Velcro cable cable ties because that helps me keep everything nice and tidy and working well. The painter's tape we can use for several things. The main things are for taping your lens focus and zoom rings in place. We're going to be actually manually focusing these lenses, and the last thing you want to do is inadvertently bump that zoom or focus ring when you didn't expect it, and you'll ruin up a bunch of images, of sub images, if you do that. Also, if you have a DSLR as opposed to one of these new mirrorless cameras, you can put the tape over the viewfinder. Make sure that if by some chance I shine my little red light the wrong way, I'm not going to get any stray light in the camera itself. I already mentioned the twist ties. So that stuff is in the field. But before you ever go to the field, you really need to do some research. You need to pick the object that you plan on imaging, and I would really start with brighter objects. And by that I mean some really nice open star clusters, globular clusters. Those are much easier to image than an obscure large nebula. So you'll become experienced at getting good images quicker if you stick to those brighter objects. Start with the Messier list and work on the Messiers that are part of the Milky Way. That's a good strategy. And then you also want to rehearse at home before you head to a dark site, because the more familiar you are with finding the objects that you want. Remember these, well, all but one of these star trackers are not go-to devices. You have to point them yourself. That means you need to know where the objects are and need to know how to find them. And a good way to do that is to practice at home before you go to the dark site. It may be light polluted. It may you may not want to actually do the imaging at home, but the time spent practicing will pay dividends in the field. A couple other additional accessories. First off, you see I've got a small video display up here. It's a 12-volt driven video display. From time to time, when I'm shooting something way near the zenith, I don't have the camera I have doesn't have a display on the back of it that I can rotate out and look at. So I either have to bend my neck, or with this one I actually can pull it up on my tablet via Wi-Fi. That works really well. But for if your camera doesn't have that, you can usually get a video adapter to help you out doing your test shots, doing your alignment, so you don't have to give yourself a slip disc in your neck trying to get the work done, get on the field of view you're trying to image. I also have a red dot pointer here. It's set up so I can take it in and out like you would a finder scope, and I have this cute little quarter 20 to hot shoe adapter post here that fits in the hot shoe of my camera, and then it has these two nuts that I can tighten up, one to the red dot finder, one to the hot shoe, to keep everything nice in place. And I use the red dot then to point the camera where I want it to go. It's very handy. It makes that process of pointing the camera where you want to be much easier than trying to do it looking through the viewfinder. I also have a magnetic compass. I use that for rough polar alignment, and I'll show you that in a little bit. So one of the things you want to do is you really want to utilize, if you can, dark skies for all your night sky imaging. The darker the better, especially if we're using a DSLR and a lens. It's pretty hard to put. I mean, you can get big light pollution filters for the end of a lens. That's doable, but a lot of urban observers are doing narrow band imaging, which cuts through the light pollution. It's really hard to get that, and then really expensive to get those kind of filters to do that for that you can put on the end of a lens. So we're doing pretty much all RGB, one-shot color imaging, and that's always best done at. Even narrowband imaging is best done at a dark site. Keep your setup as simple as possible. And honestly, after starting the way I did, this has been a real attraction for me. I can do some pretty decent imaging with a really simple setup compared to where I started. And I like to try and keep all my accessories in one place. I mean, this is kind of a standard field astronomy thing. You put your kits of different things together, so the one bag or one equipment box to take out, and you know what's all in there. And that works just as well here with a star tracker. Power everything if you can by battery power. Because and a lot of people are actually using these star trackers and are hiking into some darker places, and being able to run on battery power is a big plus. Plan ahead, be prepared, and we talked about practicing. If you have a counterweight, make sure when you set your camera up on it that on the camera tracker, make sure that you go through the process of actually balancing the camera with the counterweight. Put the camera pointing straight forward, turn everything with the weight and the camera horizontally, and move the weight until it balances. Then do it on the other side and make sure it's right. And then finally, and this was something I learned the hard way doing astro-imaging, don't overload your star tracker, because it's only going to cause you problems. I found that out overloading that Meade LX200. I went from being able to get some kind of images out of it to nothing. Here's my travel kit. I've actually traveled with this. I traveled with it, I mentioned, back to New York State. Earlier this year in March, I went over to the island of Hawaii for a week, and I took all of this gear with me with the idea that I was going to do night photography. Hard to do night photography in cloudy weather. That's all I'll say. Spent a week very disappointed. And there's always an upgrade. One of the nice things about the new equipment is that there are a lot of more choices for lightweight astro-imaging rigs. And this shows a ZWO Red Cat 51 4-element refractor with a ZWO CMOS astro camera and an off-axis guider and a guide camera. So it's possible to upgrade to quote unquote astrophotography equipment. But just remember, when you do this, you're going to have to take a computer to run the cameras. You're going to have a higher capacity power box, and with what's also not shown on here is all the extra cables that you have to have. Okay, so here's a list that we're going to run through of techniques you need to know about. Polar alignment, we'll do that in 2 steps. Focusing and framing your target. How long should your exposures be? What are calibration frames? What's an astro modified camera? Color calibration, and I'm going to spend a real brief time on basic image processing workflow. So what's polar alignment? Briefly stated, the Earth turns around north-south pole rotational axis, and we're trying to get the right ascension axis of our German equatorial mount, or the same axis for our star tracker, aligned parallel with the Earth's rotation axis. When we do that, and our camera tracker is set to the right speed, the camera tracker will keep the camera pointed on the same spot as the stars in the sky move from terrestrial east to west, which is the opposite of astro east and west. But anyway, so the idea is, if you're going to take a long exposure, you've got to keep the camera lens pointed in exactly the same spot for the whole time of that exposure, and polar alignment is how we make that happen. So how do we get polar aligned? The first part is actually, let's do a rough polar alignment. You have to really understand a couple of things. Your latitude north or south of the equator is the same as the altitude of the north celestial pole or the south celestial pole. So right off the bat, you've got a pretty good start on getting rough polar aligned. If you know your latitude, we just have to figure out how to get the star tracker pointing at that altitude. And then due north geographically, or true north, is the same as the azimuth of the north celestial pole. Okay. So to do a rough polar alignment, you can use a digital level to do your latitude. And in this case, this is actually when I was in Hawaii. So I was at about, it says minus, it's just because of the way it's tilted. It was, but I was at just slightly below 20 degrees north latitude. And you can see that I have the camera with the weight at the equatorial position pointing that way. I just finished balancing, and it was a good place for me to adjust the altitude of the star tracker. Over here, I have my trusty Boy Scout magnetic compass. You will notice something. This is the direction to point to north, but you'll notice that the magnetic needle is not pointing to north. The reason for that is what's called magnetic declination. The magnetic field varies a little bit all over the globe. So there are you have to adjust your compass in order to take advantage of finding true north. The way to do this is there's a website called magneticdeclination.com. It's got a calculator on there, and it's I've set the magnetic declination, and now I know I'm pretty close to true north. For accurate polar alignment, pretty much any of these new star trackers are going to have a pretty decent description of how to actually polar align them in the instruction manual you get with them or download from the manufacturer's website. I'm just going to point you at this particular website. You may recall back in January we had Trevor Jones from Astro Backyard do our presentation. His website is awesome for beginning astrophotographers, and he's got a whole section on how to do polar alignment there. But basically, what you're trying to do now is you're trying to adjust the reticle on your polar scope and put Polaris. There'll be some kind of an indicator in that reticle as to where you have to put Polaris based on the time and the date that you're looking at it. So you match the time and date for your polar scope, and then you look through the polar scope. You first have to find Polaris. The way I typically do that, I find Polaris in the sky using my naked eye, and then with both eyes open, I'll look through the polar alignment scope. One eye on Polaris, the other eye looking for it through the polar alignment scope. That way, I know which way I'm adjusting the sky tracker, so that eventually Polaris will show up in the field of view of the polar scope. Once I've got it in the field of view of the polar scope, it's now a question of doing fine adjustments to get it to where it needs to be on the indicator on the reticle. If your polar scope doesn't have a red illuminator, you can always use that handy red flashlight, point it in at an angle, and if you do it right, you can see the reticle and Polaris at the same time. And then use the azimuth screws to get Polaris close to where it needs to be in left and right. And then the altitude, it's usually geared kind of a wheel, a knob. It has a clamp. You loosen the clamp and then move Polaris up and down to get it where it's supposed to be. Finally, as you're getting close to the adjustments are going to be much finer. You can also use a phone app. I find this to be much easier than using the just the reticle on the polar scope. I've been using a app called Polar Finder. There are a couple other ones out there that are just as good, but that's what I've been using. And it has most of the reticles for your Polar Finder scope. So here's the screenshots from that app where you set it up, where you pick your reticle, and it's actually going to use the GPS information your phone generates, the time included, and it's going to put a spot right on that reticle where it's on your phone, but it's going to show you on that reticle where to put the Polaris. So it's very accurate. One thing, let me go back a second here. Some of these polar scopes, because there's a difference in timing when you go from the longitude where you get to a new time zone to the longitude where you end up going into a new time zone. There's a whole hour difference in there, and you could be somewhere in the middle. If you don't have a way of adjusting for that with a manual polar alignment scope, you're not going to get as close to polar alignment as you would like to have. If you're using the phone app takes that adjustment into account. So keep that longitude adjustment set at 0. I found that out the hard way. Don't do the mistakes I did. Okay. Make small adjustments, work the azimuth screws against each other. Make sure your last altitude adjustment is pushing the counterweights up, or the weight of the camera up. Don't make the mistake that I have and a lot of other people have the first time they go out to dark skies. It's easy sometimes to mistake the star Kochab for Polaris. And if you align on Kochab, which you can do, you won't get anything good. At any rate, and then again, you also have to recognize, after you've gone through all these processes, if you're sure your polar alignment is good, and you still are getting oblong stars, you may want to take a look at a couple of things. Reduce your focal length, see if that helps. If that helps, then you probably are at a focal length that's a little bit too long for your star tracker, and your accuracy of your polar alignment. The longer your focal length of your lens, the more critical it will be of errors in your polar alignment. So, but I can tell you, myself, having practiced a number of times, I've been able to get 2 to 3 minutes of unguided time on a 300 millimeter lens. And so it's very doable. And I'm not spending a lot of time getting polar aligned. So the new thing in the last few years have been polar cameras. And there's a couple of the prominent ones out there. Are they worthwhile? I'm going to leave that up to you to consider, but just keep in mind that when you add a polar camera, you're adding expense, you're adding complexity. You're going to need to take a computer into the field to align. Okay, that may be fine if you're going to be using the computer to run your camera, but just remember, it's another piece of gear you got to get out in the field and make it all work together. And honestly, practice makes perfect. I'm telling you, if you spend the time and work at it, you'll learn how to be able to do a really accurate polar alignment in about 10 minutes or less. And yes, I've been doing it for a long time on a lot of mounts and other things, but for me, it takes me 5 minutes or less, and I don't have a problem of getting 2 to 3 minutes of unguided exposures at 300 millimeters. So it's just a question of practice. Okay, focusing and framing. As I mentioned earlier, with the camera and the star tracker, you really don't have go-to capabilities. So this is like learning how to star hop. So you need to have some idea of the night sky and where your target is located in it. So my suggestion is that once you select a target and please start with brighter ones. Globular clusters are probably the best bet for starting out, because you're going to be able to see them easier and get lined up on them. Simulate framing those bright targets in a planetarium program, one that displays a field of view of your camera lens and camera. One of those is Stellarium. It's a freebie. You can do this with Stellarium. Once you've got the target down and you've memorized or even printed it out so you can see the star patterns, the bright star patterns, during the full moon, you can you can practice getting polar line, identify your bright stars, and lining up to make sure the bright stars in the FOV of your camera match what you're trying to get with your target. And as I said, if your first targets are star clusters, you're going to know you can look at your sub image and you'll know that you're pointing at it or not. Okay, so this gives you an idea. I'm actually using an older program that I have. It just seems to work a lot better for me. It's the Sky 6, and I'm locating the Heart and Soul Nebula. So this is a wider field. I know what the bright stars are looking like, and I'm going to use my red dot finder to get an approximate position in that pattern of stars. I've also gone in and looked at it in detail. So I know I've got a bunch of star clusters in here. I've got one really nice bright star, and I've circled here. This is the double cluster. This duo is very close by the double cluster. So I used the double cluster to find the double cluster to get me close. I could see it naked eye. I put my red dot on it. It showed up in the middle of my frame here, and then I moved it in my frame until I had it where I just wanted it to get outside the field of view. Well, it worked. Basically, the way I did that, it's a basic trial and error method. I bumped up the ISO and I used a shorter exposure. I pointed with the red dot. I shot an image, saw the double cluster, moved where I thought it should go, and shot again. And eventually, I got the double cluster all the way to the edge of the field of view, and then I moved the camera in the other axis. I think it was the RA axis. When you do this, though, remember, reset your ISO and exposure time to the values you plan for your actual imaging. You don't want to end up shooting at a very high ISO for 90 seconds or 2 minutes. You're not going to be able to use that data. This is one of the framing images that I took. You can't see it. The double cluster is I moved it up this way, and moved it off screen. And you can see this very bright star here, and this one over here. I keyed on those in order to make sure I knew where I was. Okay, focusing. There's several ways you can focus at night, and probably the quickest and dirtiest is turn off your autofocus, and if your lens has a focus position indicator on the barrel of it, use that. Now you're going to want to, in order to make it accurate, you're going to want to do infinity focus with something nearby that that you can focus on and see where that ring turns up. Then make sure you turn off autofocus when you do that at night. Set it here. It's a good place to start. I don't normally do this, but it's a good place to get started from. A better method now is to use infinity focus. We're turning off we're in manual focus mode. We're also turning off image stabilization. We'll put live view on the camera and make sure that exposure simulation is set as a menu option in the camera. Then if we have a bright star, or sometimes you may want to focus on a planet or a very distant light, you can use that. Zoom in on that and manually focus your lens using the focus ring until you get the smallest dot possible. And you want to go back and forth across it a couple of times, and so that you get the best feel for where that point is, and then you lock in on it. With my Canon 6D, I'm regularly able to focus by live view on stars that are 4th magnitude, sometimes 5th magnitude, without a problem. So there's a lot of stars out there close to your field of view. Some may be in your field of view that you can use this method on, and it's the one I use the most. Finally, and I tried this. I used a Botanoff mask back in the, and I still have Botanoff mask for my Astro-Imaging telescopes. It's basically a mask that puts a distortion in the light coming through into your optic, and it creates spikes. And the unique thing about the Botanoff mask is when it creates 6 spikes, this middle spike is what tells you whether you're focused or not. When it's exactly in the center, you're focused. When you're off to one side, your focus is off one direction. When you're off the other side, your focus is off in the other direction. So again, it's usually good. You want the image to be bright, so you can bump the ISO up in order to get these spikes to be bigger and easier to see. Zoom in on live view, and away you go. Don't forget to put your ISO back. And I actually did this. I don't use this very much anymore, but when I first started doing the manual focusing, I wanted to be sure that I could do it with live view. And so I started out with the Botanoff mask, got a good idea, and every once in a while I will put the Botanoff mask on in order to just double check myself. Okay, so here are some good additional resources on focusing. This AstroPix is a website by Jerry Lodricus. Jerry Lodricus has been around for an awful long time. He started out as a professional photographer and then made quite a name for himself in astrophotography with DSLRs. His website is excellent if you want to do astro-imaging with a DSLR or a mirrorless camera. So I will just point that out. Trevor Jones is Astro Backyard. He started with DSLRs, and there's a lot of good DSLR information on his site, but he's also pretty much now moved over to full-fledged Astro cameras. And I mentioned the program Stellarium. It's a free planetarium app, and you can get it at stellarium.org. So then we're focused, we're framed, and we're focused. And the question is, how long should my exposures be? And the answer is kind of relative. You want it short enough so that you avoid any tracking errors, because you're going longer than you can, your polar alignment will allow you. But you also need it to be short enough so that your brighter stars aren't blown out and saturated. You want to have the histogram of your camera to be up about 25%. And honestly, you're going to need to experiment with your equipment and see how that works out. There are some ways to calculate it, but honestly, I think it works out just as well if you do test exposures and try different lengths to see how each works out. This is from Jerry Lodrigus. It shows you what the histogram on your camera should look like. Underexposed, you're way down to the left. Overexposed, you're way to the right. 25 to 33%. Where the histogram peaks, you're in high cotton. And then there are ways for you to calculate your optimum exposure. I included this. My friend John Talbot put this all together and has done several presentations. The last one at Texas Star Party, and also available at the Advanced Imaging Conference site. Okay. So a couple of things that you want to try and do. The objective here is you want to have round stars, and I've already kind of mentioned that you want to test out your setup to see how long you can expose with your polar alignment without guiding, and keep round stars. So just also keep in mind that that time is going to change depending on whether you're at the celestial equator or farther north declination. It actually gets a little lower the farther north you go, and that has everything to do with the geometry of a sphere. Also, the other thing you want to keep in mind is if you change your camera setup, different lens, different camera, that could also change your reliable exposure time. It's different weight. It's different weight distribution on your tracker. So I would suggest, if you're going to have multiple setups, that you try them out. And then once you find this round star exposure time limit, keep track of that, make a note of it. But I would suggest you back off of it a little bit, 15 or 30 seconds, just so you know that all of your subframes are going to be exposed, and they're going to be round. And you can also do the same type of tests on stars of different magnitude to determine at what exposure the brighter stars saturate at. And again, turn your autofocus and image stabilization off. I always like to do, when I do a group of sub images, I want to get about a 5 or 6 second time delay from the time I push the intervalometer start button to the time it starts taking images. Gives me a chance to get everything nice and neat and don't bump the tripod. You also want the interval between your exposures to be at least 5 or 6 seconds longer than the exposure itself. Some of that's because you want the image to get written to your memory card. Some of it is just to give the electronics in your camera a few seconds to even out. And then I've already mentioned the painter's tape, and you should be using that before you start your sub images. Then you want to take when you do all of that, take a single full exposure image and take a look at it. Is it doing what you want it to do? The last thing you want is to start an hour or an hour and a half series of images and don't look at the first one. I usually shoot a test image before I shoot the rest, and find out, oh, I kicked the tripod leg and I've got Starlink satellite trails for scars. That's not good. I don't want to waste an hour and a half. Fix it and off we go. Calibration frames, real quickly. Calibration frames take the noise out of that is fairly constant. That's inherent in your camera electronics and your optics. Dark frames, your imaging sensor will accumulate what's called thermal noise. It's just electrons that jump into the pixels because of that the sensor is warm. The warmer it is, the more electrons jump. So it does build up over time. You don't worry about it when you're taking, a 1/100th or 1/60th of a second shot. But when you're taking a 90-second shot, that noise builds up, and you want to remove it. Bias frames, you get noise that's generated in the camera electronics, and bias frames remove most of that. And then finally, flat field images are meant to adjust for variations in your optics due to imperfections in the optics, like maybe you have a hot spot in the middle, or vignetting, or dust donuts. Okay, taking dark frames. The way I find that's optimal, once I'm ready to start an imaging sequence, the first 5 or 6 frames I take them with the lens cover on. Those are my darks, and I'll image for an hour or an hour and a half, and then I'll take 6 or 5 or 6 more dark frames to bracket that group of light frames. The reason I do this is the temperature may change over an hour or an hour and a half. So the difference in the time that the dark frames are taken helps to average out the difference in the dark current that may result because of the change in temperature. And I repeat that for every group of light frames, and finally finish up my session with 5 or 6 dark frames. Okay, so that to me is the most optimal way of doing that. Bias frames you can do pretty much anytime. Basically, set your camera to the same ISO as you plan for your light frames. Set your camera to the highest, fastest shutter speed, and take about 30 frames at this setting. And those are your bias frames. Flats are a little different. You can take what's called twilight flats. It's after the sun's down below the horizon. You've got a nicely illuminated sky. You can set your exposure time for that. You don't have to worry about the ISO, but you do need to make sure that if you're using a zoom lens, that you are at the same focal length and same f ratio for these flat frames as you will be for your actual light images. And again, it's best done with autofocus and image stabilization off. Personally, I prefer to use this well-illuminated white card. Why is that? Well, I can do this during the middle of the day. I can take a look at these and make sure that that they're nicely flat, you know, that there's no shadows in them or anything. And I can figure out when I made stupid mistakes like this. You want, don't stick your thumb in the field of view, and you want the white card to cover the whole field of view. Using a white card also allows you to, or you can do the same thing with a gray card. It doesn't matter. It makes a good flat, but you can also use the same image for a custom color calibration. Okay, so next topic. What's an astro-modified camera? I've talked about it a little bit before, and this is the best description I can give you, and that's the before and after pictures. My friend Hap Griffin has been modifying Canon cameras for a long time. His website is Imaging Infinity, and basically what he does, every stock DSLR or mirrorless camera has a color balance filter, which is placed over the camera sensor, because each of these chips has a slightly different, each of the category of chips has a slightly different sensitivity to different colors. And this color balance filter helps give an even color balance when you take daylight pictures. So here we go. I'm taking astro pictures, and I want to take images of nice red nebula. Well, it turns out that most of these camera sensors are very sensitive to darker red light. That's not good for daylight images. So this color balance filter actually cuts that light down. So when you get a camera modified, we take that stock color balance filter off and replace it with a new filter, which allows the red through. And you'll get sometimes 4, maybe more times the exposure level at that dark red than you would with the stock filter. So if you're going to shoot bright nebula, modification may be in order. So when you do that, though, you have to use custom color calibration even for your daylight images. So you may not want to do an astro modification on the picture on the camera that you're planning on taking wedding pictures or family pictures with. Okay, it's the color's never quite right for what you want unless you really work at it. Modified color camera. This came from Jerry Lodrick's website, and he said if you've got a stock unmodified camera, use built-in daylight or sunny white balance. If you use that camera with a light pollution filter, you got to use a custom white balance shot with the filter on the camera. Same thing for the modified camera. You got to use that custom white balance. If you're using a light pollution filter, you have to do the custom white balance, white or gray image with that light pollution filter on the lens. Okay, and we're getting down to the last few slides, and I'm going to go really lightly over this because processing of astro images is a a very deep subject, and but I do want to at least give you an idea of if you're just getting into it from the photography end, what you might be able to do. I mentioned the program Deep Sky Stacker before. It's really a very good program for calibrating your images and for literally registering them and stacking them, and it has built-in noise reducing algorithms. What it won't do is it won't go beyond that. So if you think you're going to put your images in the Deep Sky Stacker and come out with a finished image, sorry, it's not built to do that. What you will get is a good raw image that's been calibrated and that the systematic noise has been taken out of it. Trevor Jones has a really good Deep Sky Stacker tutorial. He uses that a lot, and he uses Photoshop afterwards. He's got a good Photoshop tutorial as well. So post-processing, you can done okay, so what we're talking about here is pre-processing, calibration, image alignment, stacking, and combining them. Once you get to that, now you're actually in the image processing, post-processing. This is done with a photographic package like Lightroom. I've used Luminar. I have Luminar as well. There's several others that will do it, and you can with a not a huge amount of work and effort, you can get some decent images. They're not going to be publication quality images, but you're going to be delighted with them, I guarantee you, and your friends and your family are going to be delighted that you're able to do them. And the more that happens, the more you're going to get sucked into doing astrophotography. And as I've said before, there's always an upgrade, and you're going to figure out ways to get better and better. And you will start to tackle programs like Photoshop or like PixInsight. So the first thing you have to do in a post-processing workflow is that you got to temporarily brighten that image you get out of Deep Sky Stacker, and you're going to have to crop it, because when the alignment's done, not everything lines up exactly. So you'll have the edges of the image that really are crappy looking, and you want to crop them out. The other reason why you do that is that some of the tools rely on understanding the histogram of the image you're working on, and if you have these ghost edges in them, those tools won't work as well as if you crop them out. Okay, we've done the cropping. The next thing is to set the black point. Okay, the way you do that, you have to find a good spot for a black point. You continue to brighten that image until almost all of the image is white. There's only a few areas that are not white, and those are the areas that you're going to look at to be your to set your black point. If you know that there may be just a small amount of nebulosity there, but otherwise it's a clean image of space, pick that one. Do a black point sample. You want to get maybe a 5x5 pixel average, and then set the black point on that spot. You'll be amazed at how quickly that transforms the look of that image into something that where the color looks kind of right. Okay, the next we've got the basic color balance done. Now you want to use your exposure tool. All of these basic image processing programs have an exposure tool in them. You want that level so that you're happy with the overall brightness. You want to be careful when you do this, though, that you don't below the brighter stars out, or the brighter parts of whatever your target object is. So you may need, at this point, and you look at it, you may need to make a few small color corrections. There's usually like a tint and color temperature corrections in these. Make sure you do that so the empty space looks gray. And then you can increase the contrast. If you think you may have overexposed the image so that some of the bright areas are too bright, you can use the highlights tool and back those off. You can also increase the blacks, because that actually adds a little bit of contrast. Just be careful when you do that you're not making some areas of dim subject matter, or actually go so dark you can't see it. And then use the shadows tool to increase the brightness in the shadows tool. At this point, you're probably going to want to do a little bit of noise reduction. And when I say a little bit, you never really want to overdo noise reduction, because it can make your images look kind of waxy. And at this stage, you want to look at the darker areas of your image and focus on the color noise. And when you do that, you also want to just maintain the sharpness of the image. Most of these noise reduction tools have a slider that says details or sharpness. You don't want to sharpen with a noise reduction tool, but you do want to maintain the sharpness that's there as you're doing the noise reduction. We're going to sharpen later on. Touch up contrast, color balance, saturation. You may need to do this again. And then again, look at the noise. You know, some noise may pop out when you touch out the contrast. You may need to do another light noise reduction, and then sharpen the image with most of these tools now have a smart sharpen or an AI sharpen tool in them, which is great. They usually do a pretty good job. Just don't overdo the sharpening. You shouldn't have stars with rings around them. That's one of the classic indications that somebody's over sharpened an astro image. Finally, come on, why didn't you go? Okay, so at this point, you can do a final touch up on contrast and color, and you should be pretty much done. And hopefully you will like the image. So again, this is just a few URLs that I want to point you to that can get you started on this much deeper processing learning processing learning process. I'm trying to not be redundant, but there's a lot of good information out there. These are some of the better ones that I'm aware of. And then finally, I was teasing you a little bit with the Heart and Soul Nebula. This is the final image that I took with my Canon camera, my Astro modified camera. It's about 6 hours of data from dark skies. I took most of this image at Okie-Tex, and I processed it in PixInsight and Photoshop. So it's a little higher end processing, and I actually probably spent 4 or 5 hours of processing this. Part of it was getting better at PixInsight, but part of it is that typically when you do these to a little higher level, you do things like originally the small stars in this image were so daunting. It really took away from the image. So I have a process I go through, for example, to shrink stars. So there's all these small little tweaks and details that you can get into that actually pull out a much better image. But you're starting out, get good images that you're happy to show your friends and family. You can do it on these star trackers and camera trackers. It just takes a little bit of stick-to-itiveness and or stubbornness, if you will, and the willingness to learn some new things. And I'm sure that within a year or so of working at this, you'll be sending me images you want me to look at because you're proud of them. Okay, and I'm happy to have you do that. I really get a kick out of seeing a lot of your astro images. Thanks for listening, and let's get to questions. I'm afraid I probably went a little longer than I should have.
It was a great presentation, Don. Thanks for all the great information. We did have a few questions in the chat feature, a lot of comments, a lot of people heaping praise on some of your astro images, but I believe Chris Morset had the first question. Chris, you want to come off of mute and ask your question?
Yeah, thanks, Joe. Don, how do you protect against light bleeding out, especially at the dark side from your live view window?
Okay, the way that I do that is number one, I don't put the automatic review on. Most of these cameras, when you shoot a frame, it'll pop up for an automatic review of anywhere from 2 or 8 to 10 seconds, whatever, right? That goes off. So I'm only turning it on when I want to. And typically what I'll do is I have a piece of black cloth that I put over my head and put over the camera when I do that. So I can see it, and it tends to block the light from other people.
Gotcha, thanks.
All right. Again, a few other comments, some comments about the Zeiss Distagon lens from Michael Lloyd. Does anybody else have any questions they wanted to ask of Don? If you do, feel free to come off of mute and ask your questions directly. Okay. All right. I think that's it. So Don, thank you so much. It's a lot to process.
Yeah, I know this is the problem. It's like it's just like there's so much to get into here, and I wanted to get as much in as the basics as I could, right?
Certainly.
But all of these different topics tend to be fairly deep. So
absolutely. As Ray Brogdon said in the chat, he said definitely glad this was recorded. So I think a few people are going to go back over this a time or two and get all the honestly, great information. Yeah.
Actually, let me put my personal email in here, and if you have any specific questions, I'm happy to answer them. So just send them to me there. If you've got an image, I've just been through an email diagnosis of somebody's problem. So and I'm happy to help where I can there too.
Absolutely. Okay. Well, last chance for a question for Don before we wrap up the meeting here. If you do have a question, come off of mute and ask it directly. Okay. Again, Don, thanks so much for the presentation. It's really comprehensive. Got a lot of good information in there. And like I said, it is recorded. It will be processed and put on the YouTube site so that anybody who wants to go back and look at it can do so, and then maybe formulate the questions they have there and then get back to you. So Don's personal email address is there in the chat, and you can reach out to him there. So again, Don, thank you very much. It's a wonderful presentation.
No problem. I hope everybody doesn't have it. I hope nobody has problems getting to sleep tonight.
Not at all. No, this is like I said, a lot of really good information. So hopefully everybody's inspired to go out and give this a shot. Like you said, it doesn't take a lot to really get started, but I think that rabbit hole gets bigger and bigger once you start to go down this path. So
it does, but that again, if you get a few of these basics down right to begin with, it makes the rest of it go easier. Okay.
Yeah.
And honestly, probably the biggest upgrade is actually learning how to do image processing at a high level.
Perfect.
Now, in other words, it's a little easier to learn. It's pretty easy to learn how to take good data.
Right.
It's using that data to every ounce of advantage is what,
manipulating the data. Exactly.
Yeah.
Great point.
Some learning.
Absolutely. Okay. Thanks so much, Don. Really appreciate it. And thank you everybody for joining us tonight. Like I said, this is a wonderful presentation. It is being recorded and will be on our YouTube page. So before we wrap up, just wanted to make mention of our next month's meeting. So the novice meeting is going to be on July 6th at 7 p.m. through Zoom. And the following day on July 7th, we'll have our general meeting. Traditionally in the past, depending on when the holiday falls on the calendar, we'll actually postpone our meeting by a week, but we figured with the timing and whatnot of the weekend, it made sense to keep our traditional first Friday of the month schedules here. So we will have our general meeting at July 7th and the novice meeting on July 6th. You can give us a view over at our website, astronomyhouston.org. More information about this meeting and our following meetings are going to be there. And as I mentioned, if you're on any of the social media platforms that we have listed below, if you want to look at this presentation or other presentations that we've recorded, you can find them on our YouTube page, and you can actually go find the live streams on Facebook as well. So we also have a Twitter page and Instagram. And as always, if you have questions, if you want to get a hold of Don and you didn't get his email address, you can send us an email, info at astronomyhouston.org, and we'll answer those questions. Or if we can't answer the questions directly, hopefully point you in the right direction. So again, Don, thank you very much for the wonderful presentation. And to everybody else, we'll see you soon, and stay safe. Take care, everyone. Have a good night.